Aloha, and welcome to this chance to learn about Fast Demand Response, or Fast DR, from the Hawaiian electric companies. At the heart of this effort is Hawaii's quest for greater energy independence. Our islands are 90% dependent on imported fossil fuel for our energy needs: air travel, surface transportation, and electricity. This is not sustainable. Hawaii's people, businesses, and government all agree that we have to use less imported fossil fuel and more of our local renewable resources. It is about improving our economy and our energy security and protecting our global environment. There are many paths to greater energy independence: greater energy efficiency and conservation, more use of our local renewable energy resources, and a smarter grid, which makes possible new customer choices and opportunities like demand response. Demand response is the focus of this presentation. This is a conventional power plant on the west side of Oahu. It uses low-sulfur fuel oil to generate electricity. Other than one plant using 100% biofuel, all Hawaiian electric generation plants use fossil fuel. Hawaii is unique in two ways. We have the highest dependence on imported oil for electricity of any state, and each island is a standalone electric grid and must supply all of its own generation and backup with no interties to other islands or the mainland. However, Hawaii does have abundant sunshine and strong, steady winds that can generate electricity. This will not only reduce oil dependence and protect the environment, it will help stabilize electric bills, and that is good for everyone. But it's not always sunny, and the wind does not always blow. This is where demand response, and particularly fast demand response, can help. So here is what we have lined up for you in this presentation. What is demand response, and why is it important? What is Fast DR, and how does Hawaiian Electric's Fast DR program work? How can your facility participate and get the benefits of Fast DR? Let's listen in on a phone call in a downtown Honolulu office building. On the line are the building manager Stuart, chief engineer Scotty, and Hawaiian Electric customer representative Nohea.
Hey Scotty, I know you've been making some good improvements here on our building for more energy efficiency, and we all appreciate that. But I'm in a tough spot. We really have to find some ways to reduce our energy costs. You got some ideas?
Well, you're right, Stuart. This building is very efficient. We've got the new lighting system, the retrofitted chiller plants, variable speed drives on all our fans, and new controls on our energy management system. This building is about as efficient as it gets. We don't think we can do much more.
Okay, thanks Scotty. Hey Nohea, as our customer account manager from Hawaiian Electric, have you got any ideas?
Thanks, Stuart, for including me in this call. You know, we do have a pilot program called Fast DR, the newest in our DR lineup. Demand response is a partnership between customers like you and Hawaiian Electric. Fast DR is designed to help us deal with fluctuations from variable renewable resources. We're looking for facilities like yours, willing to temporarily reduce electricity use when asked. In exchange, you will receive a monthly credit on your electric bill, so you can save more than $3,000 a year.
Wow, that sounds pretty good to me. Tell me more.
Let's start at the beginning. During the day, customers use electricity. We call this demand or load. Typically, demand is lowest in the early morning. As people wake up and start their day, demand increases towards a daily peak. In Hawaii, our daily peak is usually between 5 and 9 p.m. At this time, most of us are getting home from school or work, starting laundry and cooking dinner. Shopping centers are still open, and Waikiki is just starting to light up with restaurants and nightclubs. After 9 p.m., demand drops to an overnight low.
It's important to remember that for the utility to provide customers reliable service and quality power, total generation must always equal what our customers are using. Further, there is no economical way to store significant electricity for long periods to meet changes in demand. So the utility uses three kinds of generation. Here's that typical daily curve again. Baseload generators operate 24/7. In Hawaii, these steam units are the least expensive per kilowatt hour to operate. Their output can be raised or lowered, but only so far and only slowly. Next comes cycling units, turned on in the morning to meet the typical daily demand and off again in the late evening. These generators are more expensive per kilowatt hour to operate. They can be turned up or down a little more quickly than a baseload unit. If our engineers see a heavy demand will be coming during the peak, peaking units can be turned on to meet that demand. These generators start and come to capacity very quickly and are the most expensive to operate. So far, we've been talking about what the utility calls firm dispatchable generation. That is, electric generation that can be turned on or turned up to the precise amount needed. Wind and solar energy are variable energy resources, and adding these to the mix makes system stability more challenging. The wind can die without warning, and clouds can reduce the output of a solar panel. As we've seen, the system must be ready to instantly provide generation equal to demand, or the grid may become unstable. Here's a hint. This is where DR, or demand response, comes in. Now, generation may decline for two reasons. When a generator goes out of service unexpectedly for unscheduled maintenance or due to a system disturbance, or as more and more variable energy resources are added on the grid, generation may decline unexpectedly, as when the wind slows or stops or clouds hide the sun. What can the utility do when generation declines and may not be adequate to meet demand? The utility can increase generation from units already online, or the utility can activate fast-starting units if either is available. However, as we know, the fast-start generation is the most expensive. If demand is already heavy, such as during the peak, quick-starting generation may not be sufficient or fast enough to meet demand. There is another choice instead of using expensive fast-start generators. The utility can ask our customers who have agreed in advance to reduce their demand temporarily in response to our request. That's why it's called demand response. If demand declines, less generation is needed to meet it. Even if we pay some customers incentives to participate in DR, it would be cheaper than depending on these fast-starting generators. Hawaiian Electric already has two demand response programs, Energy Scout for homes and Energy Scout for business. With Energy Scout for the home, customers allow us to turn off water heaters or air conditioners for brief periods using a sort of pager system. Residential customers who participate get a credit on their bills every month, whether or not we need to turn off their equipment. Some businesses are already signed up for Energy Scout for business. This gives a bill credit to commercial customers who allow the utility to remotely turn off larger blocks of electric use for a short time. At present, both Energy Scout programs are full. We are asking the Public Utilities Commission to allow us to add more participants and continue these popular programs. Fast DR is different from Energy Scout for business, as we'll see. Customers signed up for Energy Scout for business can switch to Fast DR if they choose. Just to be clear, energy efficiency is different from conservation. Efficiency means getting the same work from less energy, like more efficient lighting or air conditioning. Conservation uses less energy by turning things off, like remembering to shut the lights when you leave a room or using an occupancy sensor to do it for you. Also, energy efficiency is different from demand response. Energy efficiency is a constant goal that you seek to achieve throughout the year. If you use energy-efficient equipment and practices, you save electricity and money day in, day out. Demand response, however, is when you agree in advance to reduce energy use when the utility asks during unusual events. These DR events are temporary, occasional, and only happen when called by the utility. All three, conservation, energy efficiency, and demand response, will save you money and help Hawaii meet our goals to reduce our dependence on imported fossil fuels. With all three, you save money by doing the right thing for Hawaii. Here are some more characteristics that make DR different from energy efficiency or conservation. With DR, action is only taken when requested by the utility. It involves temporary reduction of electric use that has been agreed on in advance. It is voluntary. In fact, you can opt out of a DR event if you must. And participation in DR trims your electric bill whether DR is used or not, and it pays an additional incentive when the utility calls a DR event. Let's look at 4 different ways demand response is typically initiated. The first is manually. When notified by phone, email, or pager, someone at your building turns off selected equipment directly. Semi-automated. When notified by phone, email, or pager, someone at your building initiates a control strategy that has been programmed into your energy management system. Direct load control. This uses a pager system that operates relays to begin load reduction on specific pieces of equipment. No action is required by anyone at your building, but a designated person will get a notice by phone, page, text, or email. Fourth is automated demand response, sometimes called auto DR. The facility receives an internet signal which begins automated load reduction through the energy management system. No action is needed by anyone at your building, but a designated person will be notified. Here's how auto DR works. Hawaiian Electric's central system operator, the person managing the grid, initiates a DR event by triggering a control signal in a system called Demand Response Automation Server, or DRAWS. The signal from there goes over the internet to a gateway at each specific facility. The DRAWS client, as the receiving computer is called, then conveys the message to the building's energy management system, which would initiate load reduction strategies. Fast DR means the load shed occurs within 10 minutes. To participate in Fast DR, a business or facility must be able to designate at least 50 kilowatts of load that can be shut off or shed manually, semi-automatically, or by auto DR. Annual credit starts at $3,000 and can be as much as tens of thousands of dollars for more load shed. We'll discuss more details later. Let's listen in again on the meeting at the Honolulu office building as they continue their discussion about DR.
Okay, so I can see why demand response will be useful in maintaining efficient generation here on the island. But Scotty, are you really sure we can do demand response?
I think so. I mean, it's only for a few hours a year, and we're certainly capable with our energy management system. What we need to do is make sure our tenants and their customers and anybody else who's using this building isn't severely impacted. Not quite sure how to do it. Nohea, you got any ideas on that?
Sure, Hawaiian Electric can help. We have experts on our team that can come out and perform a technical audit and help you find possible load reduction strategies. We'll walk the building with you to help determine what hardware, software, or system upgrades you might need. We can get you ready.
Let's take a closer look at the Fast DR program. There are 2 basic candidates for demand response: buildings where people work and process facilities where the load is predominantly machinery. You can see that on Oahu, 33% of the load is commercial, 37% is industrial, and the remaining is residential. Fast DR is designed for commercial and industrial load. People buildings, such as offices, retail, and hotels, will have a goal of reducing load without noticeably reducing comfort. It's usually accomplished through the lighting, air conditioning, and other miscellaneous equipment. Process facilities are less about human comfort and more to do with shedding load and an acceptable reduction in productivity. Facilities like cold storage and pumping applications are good candidates. Here are some general lighting concepts for implementing demand response. If you have an EMS system and it's connected to the lighting, maybe some lighting could be dimmed or certain circuits turned off. If you don't have an EMS system and can't automatically turn off the lights, then a manual load reduction could occur, room by room, through email notification, or for specific circuits by manually shutting off designated lighting in typical locations as shown in the list. Here we show a typical air conditioning system in an office building with a chiller plant in the basement and air handlers on each floor. Increasing space temperature to the thermostat is one of the most common ways of achieving demand response. It will result in a reduction on the air conditioning equipment. If this is achieved through the energy management system, it is often referred to as global temperature adjustment. If there is not an energy management system that communicates with the thermostats, there are opportunities of reducing load at the air handling unit and chiller by chilled water reset, reconfiguring the chiller line up to smaller chillers for pumps, and slowing the fans down at the air handling units. Notice pre-cooling the building is on the strategies list, and as the name implies, this takes time. However, with Fast DR and the 10-minute response, it is simply not an option. Most buildings have central plants, but some of them also have package units, and demand response can be achieved by cycling off package units. Typically, this is done by creating groups so that no package unit is off more than about 15 minutes. And when cycling package units, the compressor itself can be cut off, or sometimes the compressor and the fans. With air handling systems, demand response can be achieved either manually or through the EMS system, and global temperature adjustment is still a good way of achieving it. However, with Fast DR, some strategies to curtail load faster than slow-acting global temperature adjustment may be necessary. For constant air volume, this might involve cycling fans in sequence. If it's variable air volume, we would limit the fan speed or reduce the duct pressure to achieve demand response. Other machinery can be controlled manually or through the EMS, and the list here mentions several good candidates, such as elevators, fountains, swimming pools, garage exhaust fans, and even domestic water heaters. Cycle or shut down elevators with older motor generator sets. Reduce pumps for domestic water heater and other uses. Reduce fans for elevators and general use. Turn off all equipment not in use, including such office equipment as computers, printers, etc. Delay and reschedule dishwashing and laundry while domestic water heaters may be curtailed. Let's look at the different types of demand response for specific people buildings. Here we have offices. Office buildings are good candidates and can often achieve as much as 10 to 15% load shed. This is achieved by reducing lighting in office areas, in hallways, ornamental lighting, of course thermostat resetting, and specific measures on air conditioning. Some are able to shut down one or more elevators, and if possible, there could be printing or data processing that could be moved to non-load shed hours. Hotels participate in demand response, especially large ones. Because hotels are in a class of their own, different from office buildings or residential high-rises, we are looking for some hotels willing to take part in a hospitality project being sponsored by Hawaiian Electric, the Electric Power Research Institute, and Lawrence Berkeley National Laboratory. They achieve significant levels of load reduction by turning off ornamental lighting, signage lighting, display lighting, fountains, pool pumps, and even ice machines. Of course, we could raise the thermostats and reduce chiller plant loading. Some shut off elevators, and even others are able to delay battery charging for maintenance vehicles. It's also possible to postpone dishwashing and laundering until after the DR event. Many retail stores participate in demand response and are especially interesting if a chain of stores is controlled together. Typically, DR is achieved by reducing the air conditioning and shutting off a third of the lighting, also turning off ornamental features, marketing displays, and elevators as feasible. However, for this Fast DR program, some smaller retail stores may not meet the minimum load shedding requirements. Many institutional facilities, such as universities and colleges, can typically identify a variety of loads that will yield an overall demand reduction from 5 to 20%. They may require a special assessment due to variable occupancy throughout the year. Load shed can be obtained by resetting thermostats or adjusting the central plant, reducing some of the lighting, and turning off air conditioning and lighting in classrooms and facilities not in use. A swimming pool pump may be able to be adjusted and elevators shut off if possible. Check kitchens and cafeterias or energy-intensive laboratories for DR opportunities. Manufacturing and process facilities also present many DR opportunities, and these include petroleum refiners, printing of newspapers and magazines, as well as producers of stone, clay glass, textile, and apparel products. The manufacturing strategies generally fall into the categories of turning off non-essential process and pumping equipment. If there is a batch or continuous process, this could be delayed until after the DR event. We want to shut off interior lighting, cycle air conditioning fans, delay battery charging, and if possible, curtail air compressors. Food processing is one of Hawaii's leading manufacturing activities with a wide variety of products. DR activities commonly involve delaying the batch process and may include refrigeration. Cold storage could involve refrigerated warehouses as well as food production. We also look for DR in cold storage for some products that aren't affected by reduced refrigeration for 2 to 3 hours. We look to shutting off or reducing the speed of evaporator fans, turning off some lighting, and delaying forklift charging. Back at the building, after Scotty the engineer has looked over all of the load reduction strategies, let's see what he thinks.
Those are really good ideas. I guess others have done this. We have the tools, and it sounds doable.
That sounds great. I guess we'll need to find out a few things, like we need to know if we can implement enough measures to make a difference, and will it cost us anything to participate, things like that. So Nohea, I need some more information about exactly what our obligations will be and how we participate in the program.
I think I can answer some of those questions. Okay, so what are the Fast DR basics? Fast DR pays in two ways, $5 per kilowatt per month and 50 cents per kilowatt hour of load shed. You need a minimum of 50 kilowatt hours to load shed, and your energy reduction has to occur between the hours of 7 a.m. and 9 p.m. on non-holiday weekends. Let's look at how your building can easily shed 50 kilowatts. A typical 10-story building with 100,000 square feet of office space and a 500 kilowatt peak demand can reasonably shed 50 kilowatts. What's the math? Well, 20% of your lighting usually amounts to about 30 kilowatts. A 3-degree temperature reset can add up to 15 kilowatts. 5 kilowatts is other equipment, something like an elevator or fountain pump. There's your 50 kilowatts.
Nohea, can you go over the steps to participate in Hawaiian Electric's Fast DR?
Yes, I can. Step 1 is to schedule a preliminary assessment or technical audit. Step 2 is to assist Hawaiian Electric in performing the assessment or audit. Step 3 is to review audit findings and decide if program benefits are worthwhile for you. If yes, you work with us to develop DR response load reduction plans. Step 4 is to determine equipment, software requirements, and upgrades. Step 5 is to sign the Fast DR agreement with Hawaiian Electric. Step 6 is to arrange installation of equipment, then test and commission your DR system. And the last step is to start collecting your monthly incentives. So if you're interested or want more information, call or visit our website. If you're not sure what your building's demand is, or if you qualify for the Fast DR program, you can check your electricity bill or call the Fast DR hotline at 947-6937.
That concludes our presentation. Thank you for your interest.